Hi guys, and thanks for watching again. Today I will be showing you how to connect this 128 by 64 pixel OLED display to a Raspberry Pi. And of course how to create your own image for this display. And as you can see, this display is a little flickery. I hope I got that on camera. And that's because of the modest refresh rate of this display. So these displays are available from eBay in a range of colors, and I chose the one with the white LEDs, as you can see. Now I'm not going to tell you exactly what to install and how to do that, because that's all explained very well in a blog on adafruit.com written by Tony DiCola. I hope I pronounced that name correctly. I'll put a link to that blog in the description. The only thing which was a little hard to find out was how to wire this correctly, because the pins on this display do not match the pins described on Tony's blog. So I've connected this display using the SPI interface of the Raspberry Pi. It uses 2 more pins than the I2C method, but the SPI interface is much faster, which can be useful if you're going to use animations. So let me put this aside. And this is how I wired it. So let me see if I can get that on camera correctly. Yes, it is correct. And these are the pins on this display in this particular order. And these are the pin numbers. Note that these are the exact pin numbers on this board and not the GPIO numbers. And the ground can be connected to any ground pin, and the VCC needs to be connected to the 3.3 volt pin, which is pin number 1 over here. Now, if you've cloned the Git repository mentioned in Tony's blog, you will find a file called image.py. And Pi, of course, does not stand for Raspberry Pi, but for Python, because it's a Python script. And you'll find it in the example directory. But before you start that, you need to change the type of display you're using. And if you have the exact same display as I have and wired it in the exact same way, you'll need to uncomment the line which contains both SPI and the correct resolution, which is in this case 128 by 64. And if you start that file without any further adjustments, the display will now show the happy cat telling you it has OLED. And as you can see, I took it a little step further and created my own image using the GIMP, which stands for a GNU Image Manipulation Program, if I'm not mistaken. It's available for Windows and almost every Linux distribution imaginable, and that's one of my favorite image editing programs. So I started the GIMP using a blank grayscale image of 128 by 64 pixels, and when I was done creating this, I changed the image mode to an indexed file of 1-bit color depth and then saved the file. Now they've changed that recently in the GIMP. Now you cannot choose a file and then save. Now you have to choose a file and then export image. And there you only need to do to save it as a ppm file is give it a name with that exact same extension. So image.ppm, for example. And as soon as you hit that save button, it will ask you if you want to save it in the ASCII or RAW mode, and you need the RAW mode for this display on this Python program. Now you need to transfer the image to the Raspberry Pi if you did not create it with the GIMP on the Raspberry Pi, and then move it to the example directory or anywhere where you want, as soon as the Python script can find it. Start the Python script, the image.py script, and it starts doing this. So, in one of my next videos I will be creating some useful software for this display. Not sure what exactly, but it will be fun. And of course I'll make that software available freely using my GitHub page. So for now, thanks for watching.